Let's now consider the factor theorem. And what the factor theorem tells us is if we've got an expression such that, let's say that x minus c, sometimes we see it as x minus r, is a factor of a polynomial, then when we synthetically divide it by, in this case, let's say c, and we get a remainder of 0, then in fact, in this case, the x minus 2 would be a factor, is in fact a factor, is in fact a factor. Now, we've got to be careful here because think about this. This is x minus c. Well, c in this case is not negative 2, it's 2. Now, if we were to see x plus 2 as an example, that would actually be x minus negative 2, so that the two negatives become a positive. So in effect, you're switching the sign, I guess would be one way to look at this. You synthetically divide it. If you get 0 for a remainder, then in this case, x minus c, or x minus 2 in this case, is in fact a factor of the polynomial that we see here, x cubed minus 7x squared plus 4x plus 12. So in this case, we're asked to show that x minus 2 is in fact a factor of this polynomial, and then find the remaining factors from what we call the depressed polynomial. So let's go about this. So we're going to synthetically divide in this case by 2, not negative 2, because remember we're talking about x minus c. So that would be x minus positive 2, x minus 2. And we're going to write our coefficients of our polynomial. And let's see, I got x to the third, x squared, x, and all of my exponents descend in order down to 0 to the constant there. So we've got 1, negative 7, 4, and 12. We're going to draw our line. We're going to bring down the 1. We'll see, 2 times 1 is 2. Negative 7 plus 2 is negative 5. 2 times negative 5 is negative 10. 4 minus 10 is negative 6. And 2 times negative 6 is negative 12. And 12 minus 12 is in fact 0. So that x minus 2 is in fact a factor. We got a 0 remainder. Now I've got a depressed polynomial here. So we started off at x cubed. So this depressed polynomial then is 1x squared minus 5x minus 6. And we can go ahead and factor this quadratic. Let's draw two sets of parentheses, if you will. We've got a single x squared, so we'll put x and x in the box. My constant is a negative term. My middle term is a negative term. So I'm going to have a plus and a minus in my parentheses because that's the only way I can multiply two numbers and get a negative. One's got to be positive, the other's got to be negative. And let's see, I'm looking for two numbers that are going to multiply to negative 6 and add to negative 5. Well, I think negative 6 and 1, positive 1, should do that. So we got x plus 1, x minus 6, and then our third factor is the one that we set out from the beginning, which is x minus 2. Three factors of this x cubed. In this case, there's going to be 3 real zeros, which I think is what we talk about next. Yes, roots and zeros. So here's the factor theorem at work. If I see a possible factor in the form of x minus c or maybe x minus r, if I take that value of c or r, as the case may be, and synthetically divide that number into the polynomial function, and if I get a 0 remainder, then that x minus that number, in this case was 2, is in fact a factor of the polynomial using the factor theorem.